Black holes, the darkest objects in the universe. The universe is filled with extraordinary objects, gigantic galaxies, exploding stars, endless clouds of cosmic dust. But among all these wonders, there exists something even more mysterious, something invisible, something so powerful that not even light can escape its gravity. These objects are known as black holes. For decades, they were considered little more than mathematical curiosities, strange predictions hidden inside Einstein's equations. But today, we know they are real. Black holes exist throughout the universe, silently shaping the galaxies around them. They warp space and time, they devour stars, and they challenge everything we think we know about physics. But what exactly is a black hole? How are they created? What happens if something falls into one? And could black holes hold the key to understanding the deepest secrets of the universe? Tonight, we journey into one of the most fascinating mysteries of modern science. Welcome to the incredible world of black holes. The death of a massive star. Every black hole begins its life as a star. But not just any star. Only the most massive stars in the universe have the power to create a black hole. Stars are enormous spheres of hot gas held together by gravity. Deep inside their cores, nuclear fusion produces enormous amounts of energy. This energy pushes outward while gravity pulls inward. For millions or even billions of years, these two forces remain in balance. But eventually, the fuel inside the star begins to run out. When this happens, the delicate balance between pressure and gravity starts to collapse. Gravity begins to win. For small stars, like our Sun, the result is relatively peaceful. They slowly shed their outer layers and become white dwarfs. But for massive stars, stars more than 20 times the mass of our Sun, the ending is far more dramatic. When the core collapses, the star explodes in a violent supernova. For a brief moment, the explosion can shine brighter than an entire galaxy. But the most extraordinary event happens in the center. The core collapses inward with unimaginable force. Gravity compresses matter so intensely that atoms themselves are crushed. In some cases, the collapse stops, forming a neutron star. But if the star is massive enough, the collapse never stops. Gravity continues to squeeze the core smaller and smaller, until a black hole is born. What is a black hole? A black hole is not a hole in space. It is actually an object, an incredibly dense region where gravity is so strong that nothing can escape. The key feature of a black hole is something called the event horizon. The event horizon is the boundary surrounding a black hole. Once something crosses this boundary, escape becomes impossible. Not even light can travel fast enough to escape the gravitational pull. This is why black holes appear completely black. They do not emit light, they trap it. Inside the event horizon lies the true heart of the black hole, the singularity. The singularity is a point where matter is compressed to infinite density, at least according to our current theories. At this point, the laws of physics as we understand them break down completely. Space and time themselves become distorted, and scientists still do not fully understand what happens there. Black holes represent one of the greatest challenges in modern physics. They push our theories to their absolute limits. Falling into a black hole. What would happen if you actually fell into a black hole? The answer is both fascinating and terrifying. As you approach the black hole, you would begin to feel its immense gravitational pull. But the most unusual effect is something called tidal gravity. Gravity near a black hole is extremely uneven. The force pulling on your feet would be much stronger than the force pulling on your head. This difference in gravitational pull would begin to stretch your body, slowly at first. But as you move closer, the stretching becomes more extreme. Eventually, you would be pulled into a long, thin shape, like a strand of spaghetti. Scientists call this phenomenon spaghettification. It is one of the strangest consequences of extreme gravity. If someone were watching you from far away, they would see something even stranger. As you approach the event horizon, time itself would appear to slow down. From their perspective, you would appear to freeze in place. Your image would become dimmer and redder until you slowly faded from view. But from your own perspective, you would continue falling normally, until you crossed the event horizon. And once you crossed it, there would be no way back. Supermassive black holes. Not all black holes are the same size. Some black holes are only a few times more massive than our Sun. These are known as stellar black holes. But the universe also contains something far larger. At the center of nearly every galaxy lies a supermassive black hole. These objects can contain millions or even billions of times the mass of our Sun. Our own galaxy, the Milky Way, has one of these giants at its center. It is called Sagittarius A. This black hole contains the mass of more than 4 million suns. Despite its enormous mass, Sagittarius A is surprisingly quiet. But in other galaxies, supermassive black holes can become extremely active. When gas and dust fall toward a black hole, they form a swirling disk known as an accretion disk. As matter spirals inward, it heats up to millions of degrees. This process releases enormous amounts of energy. In some cases, black holes can produce powerful jets of radiation that shoot across entire galaxies. These jets can travel at nearly the speed of light. Supermassive black holes do not just sit quietly in the centers of galaxies. They shape the evolution of the entire galaxy around them. The first image of a black hole. For most of human history, black holes existed only in theory. Scientists believed they existed, but no one had ever seen one. That changed in 2019. In a historic scientific achievement, astronomers revealed the first image ever taken of a black hole. This remarkable image was captured by a global network of telescopes known as the Event Horizon Telescope. By combining signals from observatories around the world, scientists effectively created a telescope the size of the Earth. The target was a supermassive black hole located 55 million light-years away in the galaxy M87. The image shows a glowing ring of hot gas surrounding a dark central shadow. That shadow is the black hole itself. It was one of the most extraordinary achievements in the history of astronomy. For the first time, humanity had seen the silhouette of one of the most mysterious objects in the universe. Do black holes live forever? It might seem like black holes are eternal. After all, they consume everything that comes near them. But surprisingly, black holes may not live forever. In the 1970s, the famous physicist Stephen Hawking made a remarkable discovery. According to quantum physics, black holes should slowly lose energy. This process is known as Hawking radiation. Over extremely long periods of time, a black hole can slowly evaporate. For small black holes, this process could take billions of years. For supermassive black holes, it would take far longer, trillions upon trillions of years. But eventually, even the largest black holes could disappear, ending their existence in a final burst of energy. The biggest mystery. Black holes may also hold one of the greatest mysteries in physics, the information paradox. According to quantum mechanics, information can never be destroyed. But if a black hole completely consumes matter, what happens to the information contained within it? Does it disappear forever? Or is it somehow preserved? Scientists still do not know the answer. Solving this mystery may require a completely new understanding of physics. Perhaps a theory that unites quantum mechanics and gravity. Some researchers even speculate that black holes could be connected to wormholes, shortcuts through space and time. Others believe they could be gateways to entirely new universes. At the moment, these ideas remain speculative, but black holes continue to challenge our understanding of reality. Black holes are among the most fascinating objects in the universe. They are born from the violent deaths of massive stars. They warp space and time. They shape galaxies, and they challenge the very foundations of physics. Yet despite decades of research, black holes remain mysterious. What truly lies beyond the event horizon? What happens inside the singularity? And could black holes reveal the ultimate laws of the universe? The answers may change everything we know about reality. But for now, black holes remain the darkest and most intriguing objects in the cosmos.